All right. Okay, welcome everybody. So we're going to today talk about, I think, something pretty exciting. A lot of times we've always had to make this decision of which direction we want to go, and talking here about Azure Container Apps, and how we maybe not have to make that decision anymore. So we're going to talk about serverless or Kubernetes, and not really having to decide between that. So let's talk. So there's really three main goals that I'm hoping to achieve, hopefully that you get out of this talk. The first thing, what is Azure Container Apps? I guess how many people have used Azure Container Apps here right now? Okay, about half. So perfect. So I'll do kind of introduction about what that is and how it's different than Kubernetes or AKS and other container services in Azure. Then we'll talk about how to actually use them. I'll do some demos of actually building them and different ways to use them. And then lastly, just kind of wanted to talk about a little bit about like, when should you use container apps versus some of the other options in Azure? Oops, I just realized I didn't have any slide about me. So I know I mentioned here before the recording, but my name is Mike Douglas. I'm SVP of Digital Consulting at Lenavi. I guess I did put a slide in here about me, and I usually don't like to talk too much about me anyway, but just a long time, I like to do a lot of presenting and sharing knowledge that I learned. I'm a Microsoft MVP. Also, one of the things I really like to do is in the community is I'm a robotics coach for a competitive robotics team of 7th and 8th graders. And so we compete with other teams here in Nebraska, and it's a lot of fun. So I really enjoy doing that. So that's just a little bit about me, and let's get on to this here then. So the first thing is, what are container apps? So the first thing I wanted to talk about with this is, before we start talking about the containers and container apps, just kind of want to level set, just kind of give, kind of take a step back and really kind of explain, like, as an application developer, like, what are the things that we care about or want to care about, right? We want to care about adding innovation and building the apps. We don't want to care about the infrastructure and a lot of the extra stuff that we just want kind of provided for us. So in Azure, there's multiple options for that. The first one is infrastructure as a service, or IaaS. And that's very much like we would have done on-prem, where we're talking about virtual machines. And with that, we have to really handle all the stuff around the virtual machines, whether that's patching, backups, all those kind of, patching, OS upgrades, all those kind of things. So, right, we don't want to really deal with any of those things. So that's to really try to stay away from building any systems using IaaS. The next two options are really platform as a service and serverless, and they're similar, but there's a couple distinctive differences. But with platform as a service, it's really nice because it is built on top of the infrastructure, so we don't have to worry about it as application developers. And really, all we need to do is be concerned with picking the configuration that we need from a CPU and memory for that. So we don't have to then worry about the underlying structure there. We still need to basically reserve kind of that compute resources. We can't scale up or can't scale down, but it's usually kind of a consistent cost that we'll pay for the entire month with PaaS resources. Whereas the one difference with serverless are traditionally more of a consumption-based model. And what I mean by that is you really only pay for what you use. And so examples of that's like Azure Functions and now container apps. You basically pay for the number of requests that are coming about it, which really, I think, offers some real interesting cost models that is helpful. And with that, you really are not concerned as much about the CPU or memory. It just really pay for what you use. And so that's what we're really going to be focused on today, is that serverless kind of box of what we're interested in. Now, from a container standpoint, there's a number of container offerings in Azure that we can use today, whether it's more full service orchestrators like AKS or OpenShift, or some of the other options there of PaaS services, like we have of whether we're using like web apps for containers or container apps there. So the number of, and then there's even ones where like Azure Functions, we could do it with a container, without a container, and really app services too. So a lot of different options today. We're going to primarily focus on Azure Container Apps, but at the end, I'll talk a little bit about some of the pros and cons between like Azure Functions or App Services, and AKS and Azure Container Apps. So from an Azure Container Apps perspective, it's a serverless platform, meaning we're only going to pay for consumption. I'll talk a little bit about the billing and how that works with it in just a minute, but it is powered by Kubernetes. And what's really nice is it's kind of an abstraction layer on top of it. How many people are familiar with Kubernetes or use Kubernetes a lot? One, two, a couple of people. So if you use Kubernetes, you'll feel very comfortable with this, right? You'll understand a lot of the concepts. It'll make sense. But if you have not used Kubernetes or not used AKS, you'll be able to pick up these concepts pretty easily and not even realize it's part of Kubernetes itself. So that's really nice there. It's very general purpose. You can basically run any kind of workload on these, whether they're microservices, APIs, web front end applications. You can even now do, they have container jobs that you can set up to even run stuff on like a schedule and things like that. One of the things you could do is, one nice model is it supports event-driven architectures, which is really nice when it comes to like microservices and things like that. You could do scale based on HTTP calls. So you can have it automatically scale up your instances of your container app through like HTTP. You can also do more traditional like CPU or memory. So if you start hitting kind of the high thresholds, you can actually trigger the additional instances. So if you're familiar with Kubernetes, you could do a lot of that with that. And then the last one is Kata, which is really nice. And that's more of a proactive scaling model where you can actually, if your services are reading more from a queue, the more messages that come in the queue, the more instances it will know to spin up for that. So that's really nice. And then lastly there, it can just kind of touch on it, but you can run basically any workload that any other service could run on those. From a concept standpoint, again, these will be very familiar to if you're using Kubernetes, but the core of like where your code runs on is a container. And so that's one of the core key pieces there is that it's different than some of the other like PaaS services or even like Azure Functions that's serverless. You do put this into a container, and I'll talk a little about pros and cons of that. You also have the pod concept of running multiple containers together under the same memory and CPU context. And then you can basically, the instance of that, or number of instances you can use it with replica. So again, if you want to have like 4 instances, it's 4 replicas. The other, I think one of the real interesting concepts is revisions, and I'll talk about that, but that's basically a snapshot version of what you've deployed. And then around that is your container app itself. So each of the container apps you could have multiple revisions of. And then last, and I think this is the most interesting part of this, is the environments. And I'll talk a little bit more about that, but that's really the security boundary that your apps can run under, where you can run them together. And I think it's a key differentiator in my mind between some of the other offerings like Azure Functions and stuff. From a container standpoint, you can run essentially any container, which is nice. The one thing you can't do is if it needs like root access or something like that. I've not seen a way yet to do that inside of container apps. If you need to specify a certain minimum number of memory or CPU, you can do that as part of the definition, similar to how you can do that in Kubernetes. You can also set health probes, which are really nice too, because you'll want to make sure your app is up, but then you also want to make sure it's actually ready to receive requests from that. So you can set up those different health probes to really understand that. And I already mentioned this too, but it supports that concept where you can run things as a pod in kind of that same memory space and use things like sidecars along with that. All right, so let's talk about, I don't trust that. Let's talk about the revisions. So I think this is pretty interesting with what we could do here. With revisions, we can basically get an immutable snapshot of what we deploy. So one of the concepts that with containers is you really never want to edit anything that you are deploying in there. You always want to create a new container and deploy that as a new version. So you want to have that be immutable. But basically each version that you deploy of your container is a revision, and it handles a lot of the revision. You can do multiple revisions at the same time. If you do one revision at a time, it will actually do as kind of a zero deployment or zero downtime deployment, and it will deploy your new version, and it'll start, and basically it'll wait for the new version to be ready to accept requests before it'll shut down the old one. And so that kind of gives you that a much better uptime percentage there. The other thing you could do with multiple revisions, you could have those running at the same time and support things like A/B testing. You can give like 50% of the traffic to one revision and 50% up to another, or do things like blue-green deployments to where you might want to spin one up, run a few things, make sure everything's up and running and live, and then do the switch over. You can do things like that. So it's really nice to affect that. The most of the things are immutable, but there are some application scope changes that would affect multiple revisions. But for the most part, you can think of the revisions as kind of a silo of changes there, which is really nice. The other real interesting thing is the labels that you can set up. And I'll show that here in just a few minutes with the demo, but you can actually label the revision to, like, let's call it like a test. And so with that, then you get a URL for your testers to be able to hit that, and you could keep deploying new versions or new revisions essentially, and keep that same test label so that your testers are always getting to test the latest and newer versions and stuff like that, but you don't have to keep giving them new URLs. So again, some really nice concepts there from a revisioning standpoint, and we'll show that here in just a few minutes. The last one here is the environments. And again, I think this is pretty interesting. Probably to me, one of the differentiators between some of the other services, it provides that secure boundary for the services. And what it does is it basically has a virtual network behind it. And by default, it will create a virtual network that's kind of outside of your purview, or you can set it up to actually include your own virtual network and subnets and all that stuff and have more full control. And then you can do more advanced things that I'll talk about here too. Getting a little ahead of myself on that one, but you can basically utilize that. And what's really nice then is because it creates that security boundary, it makes it really easy if you have services that need to talk to each other to basically provide the access to do that. And then the other, you might not want to do that though for some reasons, because you just may not, you do want that security boundary between your services. So it does provide that. And I'll talk a little bit more later about why some of the other reasons. Yeah. When you run container apps, even when you set up one container, you have to specify an environment. But you can basically just have that, like, you're not charged for an environment. So if you don't really do anything with it, it's nothing more than just a concept that's created. I'll show when I create one, but you have to specify it. But it's basically just it creates a virtual network on like the Microsoft scope. I can't remember the next thing. Yeah, it's similar to that. But yeah, with that sort of somebody, you can just, really specify an environment, or you can build an environment and then build the app services under that. So yeah, there is no concept of, those are just out and running. You can install it to a virtual network, but you don't have to. Yeah, yep. All right. So last thing here too to kind of talk about is the billing, because I think this is a real important part. Again, because this is serverless, you're really only paying for what you use. You can actually have these scale to 0, which is really nice. So if you actually have a running instance and you're not using it, scale to 0, and then you don't pay for anything at all. Obviously, if you've used like Azure Functions and have done similar, you kind of know the pain of the cold start. And so you get some more like, the cold start's going to take a lot longer depending on how long your app takes to start up, that you'd have to do it. But you basically pay for the container app, not the environment. And like functions and like other serverless things, you kind of get the first X number of requests and stuff free. In this case, it's like 2 million and then so much CPU and so much memory each month, which is really nice. And I think that to me, that's really key because you can utilize that in your non-prod environments and not have to pay for really your non-prod environments. And maybe even your prod environment if you're not hitting those thresholds every month. So it can really bring those costs down. The other thing too is you can pay for dedicated instances where you're actually have them already pre-warmed. The nice thing about this over Azure Functions is you have to go to Premium Elastic for Azure Functions. And at that point, you're paying for all the other features that come along with it, like the private networking and some of the other things. So you end up paying, I don't know, it's like $90 a month usually for like one instance of that. Whereas this, you can use what they call idle time, pay for idle time to keep your app warm. And it's like $30 a month. So it's I think a cheaper option to do that too. And then the last thing I think is really interesting is when we set stuff up, we like to use infrastructure as code. We want to make sure that when we deploy to test, it's a practice run to deploy to prod. So we want to make it as prod-like as possible. We usually we usually don't have as many instances. Maybe you try to go down levels on the CPU and things like that. But if we're doing things like private endpoints in production, that forces us to bump up to those premium SKUs, which make it a lot more expensive. And now we're deploying premium SKUs to non-prod environments and paying for really stuff we don't even need. So that's always been one thing that's always bugged me about, whether we're using app services or functions, that we have to go to that level. And the nice thing about this is because it already has the virtual network built in, you don't have to pay anymore for those services. So in the non-prod environments, if you're using the container apps, it's really just free if you're not calling it. So to me, that's a pretty big cost savings when you start talking about dozens and dozens of apps in your non-prod environments, unless you pretty much blow them away. But I just think that's one nice thing about this. All right, so I think we're ready for our first demo. Any questions before I get into the demo? Apologize, I feel like I'm running out of air just a little bit. I'm getting over a cold. So talking loud is taking out a little bit of air. Okay, so let's create our first container app. All right, here, so you'll see some of the ones I've already created out here as a preview of this. We'll go ahead and create our first one. And we'll go ahead and use our environment there. We'll create a new resource group, Omaha Azure UG. And we'll do this. We'll say first container app. There, and then for our container environment, I don't think we can, I think we have to specify one in here. So we'll choose this, we'll create a new, this will make it take an extra minute, but that's okay. We do have the ability to create either consumption only, and there's the option to create ones that actually do support more dedicated plans if we want to. But this case, we'll just create our OM, AZ, UG, EMB. Great name, huh? We're not going to do any of the redundancy, but there's, if we wanted to, we could set the virtual network up. We're just going to let it use the default virtual network and go ahead and create that because oops, I'm sorry. It's always different here. So we got the basics now. The next thing we want to do is choose our container app. So we'll come back to this setting here in just a little bit, but if we uncheck our quick start, this is where we can actually specify like our Azure container registry and then select the images that we want to use. So if you're familiar with AKS deployments, what we typically do is create the container image itself as like a pretty much like a binary that we store into a container registry. And then when we're ready to use it, we tell Kubernetes, the control plane, to go create this container as an instance. And so that's what this is doing right here. It's telling us to do that. We'll come back to that though. In this case, we're just going to use the quick start. It's going to be a simple hello world instance there, and then we'll create it. So this will actually take just an extra minute. The container doesn't take very long to create, but the environment will take just a couple extra minutes there. So we'll come back to that here in just a minute. So a couple of things that I'll show you once we get the container created in there is the first thing is about ingress. And so, excuse me, for the ingress, for especially with like Kubernetes or AKS, there's a lot of advanced settings you could do. And you use things like an ingress controller, like Nginx or something like that to create your ingress controller, which is really just how your traffic comes into your Kubernetes service essentially, and then how it gets directed to some of the services or the other containers throughout it. So you can do things like a gateway mapping and things like that. In this case, it's pretty simple. It's either public or external, or it's internal. And based on that, it's really just a slight naming convention different. You can see the one main difference here is if we specify internal, it just adds the internal subdomain to the URL. From a discoverability standpoint, it follows the same naming convention no matter what you create. Obviously, you can put a custom domain in front of it, but the default one here is you have like your app name. You have your, and that'll include it too if you want your label on there, your unique identifier, which just a name that they'll auto create for you, the region you're in, and then the Azure Container Apps.io for your full naming convention there. And so those are a couple of kind of the things that we'll see here. So let's see if we're created there. All right. So now in our first container app, there's a few settings. The first thing you'll notice, there is our URL. And you can see first container app as the name we provided. This is our custom name, the region, and then our name there. So we'll go ahead and click on that and see how exciting of a container this is. You're either getting to witness the cold start of the container app, or maybe it's just a slight hiccup on the internet connection. It seems a little slower than normal. But isn't that how always things work when there's a demo? Interesting. Let's click on that one more time. Well, let's go back here and let's take a look at a couple things. There should be a provisioning status succeeded. So it has been running. And not really probably going to see any data there. Huh. Which region? Yeah. Right. Yeah. Yep. Yeah. You select the. Yeah. I'll show you that in the second demo, assuming the first demo actually works. Yeah. So we'll come in and we'll look at that. So the let's see. So like here's the ingress piece that I mentioned about being able to choose whether you want your traffic accepted from anywhere or limited to just the network. There's, what do you know, there finally started. All that for just that. That's pretty sad. But here's the container. So it's basically, we have it running. There's your URL that we have with that. So we'll come back and we'll look at a few more of these advanced settings. We'll talk about some revisions here in just a minute. So the last thing I want to kind of mention from an advanced scenario, and this is newer, so this has been within probably the last couple of months. One of the things that have been limiting the use of container apps is being able to control your egress traffic, meaning if your container app is actually calling out to a service, like say it's calling out to the weather, National Weather Service API to get weather data. A lot of compliance reasons, they don't want you using anything that they can't actually have to prove that something's not actually going out, right? They don't want, private data, HIPAA data, stuff like that being leaked out of your application. So it would ensure that there's nothing from an egress standpoint going out. And with now with Azure Container Apps, you can actually support egress in those to have it controlled. You can do user-defined routes to have it come out through a firewall, and then you can actually build rules to say, yes, you can go to the National Weather Service. No, you can't go to anywhere else. And then control that traffic out of there. Things you've been able to do, but are still really nice too, is you can create this as a internal only network and put things in front of this like an application gateway and a WAF to control the traffic in there. So you can, excuse me. So you can actually do load balancing, things like that to going into there. So it's nice that some of the apps, some of those more advanced features that you might not have been able to do before. Any questions on that? All right. So now let's as exciting as a 2-minute to load Hello World container was to see. Let's actually create a more advanced scenario here that you'll actually get to see a few things. So we're going to create a weather app and have it actually call an API to get the weather data behind it. So let's go ahead and create that. All right, so here we're going to go to Visual Studio. We'll go ahead and create an API. And this is pretty basic here, but we'll do a UG forecast API. And then we'll just call the solution UG forecast for that. Keep it pretty simple. I'm going to go ahead and not choose the enable Docker because that's something we're going to do, but you can actually enable it later. So for this example, I'm just going to show creating that. And yes, everything else looks good. So we're just going to create a real simple forecast API. We can launch it and it'll basically just return back this. But if you've got any application and you want to make it a Docker container app, you can simply just right click on it, come down to add and choose Docker support. You get to choose Linux or Windows. In this case, we want Linux on it, and then it'll actually create the Docker file for you with this. And you can see it's essentially just exposing the application services. So pretty basic. You might have to, typically you'd probably need to customize these, but you can see here where base image and using the application and stuff there. The nice thing is with Visual Studio, if you've never done that with Docker, is you can actually run the Docker container locally and still support things like debugging and other things like that. Probably should have not done that because it's going to take too long, but you always get tempted to go off the demo script here live. So I guess I've gone this far. Might as well just finish. So this will show, it should just launch the browser and then we can put in the /weather forecast to have it return back the JSON to show that. Sometime. I'll actually try to bring the swagger up. So who knows, I probably got all off base here. You shouldn't have gone through that. Anyway, let's just do it live. Didn't go off script. All right, so there's our API that we created. We've added the Docker file and the Docker support. Now what we want to do is deploy it to Azure. So normally we want to run this through a pipeline. I'll talk a little bit about pipeline at the end. In this case, though, we're just going to right-click and do publish. We're going to publish it to our container app. You can see some of the other options here for doing a container application. We've got our subscription specified. We've got our resource group here that we want to deploy it to. We'll create a new Azure container app. Name it very simple. We'll specify the, I call it the Omaha, there it is. Gosh. The container app environment, that one's good there. That was created, and there's our container name. So that's creating this. This will create the publish file. Or actually, no, this is creating the container app itself. So this will take just a second. And then it'll create the, and then we'll want to actually create the registry for this to go into. Like I mentioned before, is we want to, actually, no, we're just going to, for sake of time, we'll just create next. We'll just choose the same registry container that I used before. There's two ways you can actually build this. The .NET SDK now includes a way to build this. I've not had much luck with that, so we'll just use the old way of doing it with the Docker desktop, which I have running on this machine already. That's required to basically build and publish it. And so now let's go ahead and publish that out. And this will take just a second. You can see down here, it's building the container local, and then it's going to push that up to the container registry. Should all go with just a few seconds. Right, publish to that. Now it's actually deploying it to our container app. When it's all said and done, it should show us a browser to actually run this. And so we'll do our weather. There it is. There's our different weather, and you can see we got a lot of different scorching to freezing. So it looks like it is probably accurate from Omaha weather standpoint to go from cold to hot there in just a couple days. But that's our service. And so if we come back here to our container, come back here, look at our container apps. We'll see the new UG forecast API, one that we just created. In there, we'll see that we can change the ingress that we want to do for this. And we want to actually make this private because we don't want anybody to access our API. We only want our front end to be able to access that. So we'll go ahead and save this. Well, that's updating. We'll switch back. We'll create our front end for this, which will be just basically repeating what we just did. So we'll create a Blazor server app. We'll call this UG weather UI. We'll go ahead and enable the Docker from the beginning in this one. Let that create the project. We're going to make our one scary coding change here. So what this does is we'll just simulate basically the same thing the API is probably doing, is it's going to simulate the that it's actually getting data from somewhere. What we're going to do is we're going to have it call to our new service that we created. as async there. So now we've got our service. The only thing we need to do is specify the actual URL to where we're going to. That window, apparently. Interesting. Let's get different behavior on a smaller screen. All right, so there's our service. So the one thing that we'll want to do is grab the URL, and it's now saved that we're limited. So what we should see that's different. Let's grab the application URL, switch back. Apologize, jumping around kind of quick. We'll look at it here once we paste it in. You'll see it's the same URL, but now there's that internal subdomain with that. So let me go ahead and publish that. And Azure. Why I can't remember this. So now this will basically create that same thing we did for before. And it'll create that, and then we'll have we'll just use the same container registry, finish that. Now we'll publish this, and if we're lucky, when we make a call with our front end, we should be able to get the actual weather API from our service. So while that's happening, like that's great and all the hard code, that URL. Obviously, we could use things like configuration, but ideally, what we'd want to do is have some oops, I bumped that. Have some way to actually do that in a smarter way, and that's what we'll show here in just a minute. So now we're publishing our app. We should have that really quick. So while we're waiting for that to publish, I'm going to actually come in here and we're going to actually go to the pages, look at our index. We're actually going to say, we're going to call this, there actually works. We're going to call this beta. And so we'll come right back to that. But here is now our running container app. We have our Blazor server app running. Always has a counter piece to click the counter. And then here's our fetch data. And this is actually returning the data from our API to that. So that's pretty exciting that that's actually those two services are talking with it. Now what we want to do is show the revisions a little bit. And so I'm going to actually deploy this slightly different. I'm going to create a new published profile. And I'm just going to publish this to the Azure Container Registry. And finish that. So what this has done is now created a new version of our application, and we basically added a new, we should be able to see it when we actually run this here. On the home page, it should say beta next to it. So once that's published, we'll come back to here, and then we'll actually have it support. We'll set up the, let's refresh this. we'll come down to our revisions. We're going to change our revision mode to multiple. And you can see right now, all of our traffic is set to go to this one revision. And then we'll create a new revision. So let's just make sure our app is deployed. Can do this a little bit in parallel. Okay, so published. So we should now be able to create a new revision. We'll come out here. We'll call this our kind of, so we call it new version. We'll come down here to our image, and I actually want to edit this. So I want to make sure we're picking the latest version of this. So if we come down here to our Azure Container Registry, we can see here's the image, and then here's the image tag. So each deployment you get, it gets a unique tag on this. Will also be, oops. Fail. I wanted to make the UI. Sorry about that. We want the container apps. You guys saw the U for UG and this. So this is the one we actually want to make to have multiple revisions. Shouldn't hurt us that we did that for the other one. So now we have multiple revisions set for this. All right, so now we'll create our new revision. And now we'll create our name prefix here. We'll just call it new. Let's go edit this revision that we want to actually pull down. Because we really don't want to pull down the same version. We want it to pull down the latest one, which is the one we just pushed. As you can see, you can specify some of the additional things. We can specify scaling rules, all that type of stuff, like we mentioned. But in this case, we just want to set up 2 of them. Once we have both of these running, we'll get to see, we could choose the amount of traffic for each of them. We can also see, well, once it's up and running, you can see the running status is still activating. Once we do that, we'll actually see this URL, which will actually have new in the prefix with that. And so once we click on this and it's working, you can see we have the beta on that versus that was fun. All right, I guess we don't have that one open and running anymore. So we'll come back here. Oops. Sorry about the screen. There, what we can actually do now is we can set this traffic to like 50, and we can save. And what this will do is basically load balance our users. Like if we want to do some A/B testing and see, you know, are we getting better results with one way or another, that we can actually test that. So I'm just coming back here to our main URL that we have. And you can see that it already showed the beta version, but if I keep refreshing, there's a version of it that is the one version of it that we click it enough times, there's the other version of it. So you can see it's kind of doing that 50% load balance. So really nice capabilities of that. All right, so the last thing I wanted to show here is now, you know, one of the things we did was we had the URL hard coded. And so if you're thinking about for one app and an API, that's not a big deal. But the idea, if you have like 20 or 50 or 100 microservices and an app running, like to try to connect the dots of all that, it gets to be really tough. And there's a thing here. I can't alt tab and talk at the same time. A feature called Dapper. What Dapper is it's it's basically a developer tool that will help you do things that are cross-cutting that you normally have to write implementation for. And you can see there's a number of different things it provides, but it's an abstraction layer. So what's really nice is if I need to do things like state management, I don't have to worry about if I'm writing to Redis cache or writing to a file system. All I want to do is say save state or get state. And I don't want to worry about the implementation. Or maybe in dev, it's one thing, or on my machine, it's a local file system, but in production, it's a Redis. Or maybe it's SQL Server, right? Doesn't matter. It abstracts that pub sub, bindings, actors for like a or microservices there, secret handling, a lot of different capabilities there just out of the box that you get from this Dapper. And one of them is the service to service invocation. That's one we're going to show you real quick. And so what that means is we have today our 2 containers running, our weather UI and our forecast API. We're going to enable a sidecar for Dapper for each of these, and then have basically the Dapper API talk to those so that these 2 services can talk without me even knowing what those 2 are. And what you'll see is the API or the call is through a local host. And so what that means is these are basically running on the same machine. So it's just like we're on the same box. And there's invoke and there's a number of other ones that we have. So let me show you what that looks like. And then we'll wrap up our talk. Let's see. All right, so how we can, oops, that's not what I wanted. So what we could do is actually come in here to both of these. We could come down here to the Dapper setting. And I can go ahead and enable this. I can give it an ID if I want. So in this case, I'll just do forecast UI. And then these are running on 8080. And I'll go ahead and save that. We'll go over to our forecast one, do the same. And what this has done is basically turned on those sidecars. Come on, Azure. All right, so that's been successfully implemented. And now we want to enable it here. This is going to be our forecast API. And again, port 8080. And while I'm in here, I'm actually going to just turn off this. So we are going to deploy a new version. I'm going to, oops, to single. Yeah, I want to switch it back to single mode. All right, so while that's switching back to single mode on the API, no, actually, it doesn't matter. On the UI side of things, we're going to come back here to this code. And instead of putting in this URL to this specific call, I'm going to actually change it to actually be this local host. And I'm just going to say, I want to invoke the forecast. And here we change the name. So it's forecast API, and we're going to call a method of weather forecast. And that is going to be the change I'm going to make. So we'll do that. And then Dapper will really be able to connect these 2 so that they can talk. So I'm going to deploy this one now. Publish. We want to do the other publish to weather UI. So this will build a new version and then deploy it. And then we'll get to see the application now talk to that service. So I know we're getting kind of close on time here. I'll come back to this here just when in a minute after it deploys. Just one last thing I wanted to talk about is, oops, if you're actually doing this more in a production stage, you want to use it more of a pipeline. This again is where we leverage both kind of a push and a pull model. So from a pipeline standpoint, in our build, we're going to actually create the image, and we're going to push that image to the container registry. And then we're going to tell the container app, just like we're doing through the right click and publish, to then tell it to deploy your new version of the application and how many replicas and all that stuff. And it will pull that image from the registry and then deploy it into the container app itself. So it really follows the same process. If you deploy containers with like AKS or anything like that, it works very similar there, but that's how you do the pipeline. So last piece, just kind of the quick summary of kind of what we talked about. And kind of what we're building, the first question in my mind is, do we go containers or not containers? So if you haven't made the jump to containers, there's definitely stuff to consider. With no containers, we're really just worried about building a zip file, building that package. We don't have to really worry outside of the binaries in the application much. One challenge could be is your dev environment or your environments could be slightly different than what you're building locally. I mean, most of that stuff with like NuGet and stuff like that hasn't been as big of a deal. You do get kind of environment lock-in on some of the services, like you might be building something specific for Azure Functions, would say. From a security testing, you're really only concerned about your code and the dependencies that you're using. You're not really worried about testing the infrastructure and things like that. And you don't have to worry about any kind of OS or any patching of that stuff. From a container standpoint, one of the real advantages of containers is whatever runs you locally on your machine is the same thing that's going to run in production. It's in a container, it's going to run. You have portability across multiple hosting options, whether it's AKS, whether, Google Cloud, AWS, to do that. I think you have better practices around like immutability with how you're building the containers, where you're really forced to not edit those, where I think, sometimes you can go out to your web server and edit files you might deploy there. From a vulnerability standpoint, one additional thing you need to worry about is the container vulnerabilities. And, for your container, it's not that big of a deal. You just go out and get the latest version usually of that base container. But one of the things we found in like AKS, we're using Aqua to scan the containers in there. And it was flagging all the Microsoft containers, which we had no control over. There's like an OMS one, there's one for like networking. And those are the ones that had all the vulnerabilities. We're like, these aren't even exploitable. But our security team was like, they're still showing red. So we had to work to do that. And it was kind of a pain because you have to like update the nodes, update those services, and they were always behind. And so it was kind of a cat and mouse game. The nice thing is with container apps, that's all abstracted. You just have to worry about your container, but it is something else to be thinking about. And then the last thing, containers is something, right? There's the Docker file I showed. You have to, learn that, kube control, some of the command line capabilities, or some additional things. But if you have a power user, that's really, that's probably what most teams need. This was just a graphic I made to kind of represent, I think, kind of the total cost ownership of the different options. And if we're talking about a handful of, one or two services, function apps, app services, I mean, those are just really easy. You just deploy them. But you have to worry about the networking and a lot of the, the bicep or the ARM template for each of those. And the complexity could kind of scale up and get harder as you have more of those and if they need to talk to each other. On the flip side, with AKS, if you're just deploying one API to AKS, you're going through a bunch of stuff to just deploy one service. And so from a cost standpoint, that's a really expensive API. There's also a lot of things you need to consider when you're doing that. And there's a long list of those. I won't go through all of them, but a long list of a lot of those things that you have to kind of really consider for that. But if you're deploying like 100 APIs or you have a large, 200 developers, and you don't want them to have to worry about the underlying infrastructure, it's a great option. Whereas in the container apps, I just kind of feel like is in the middle. The cost, I think, is relatively low and doesn't really grow the complexity doesn't really grow. I think the environments is a big piece of that. So that's where I really think there's some advantage to doing that. And then you get a lot of the kind of out of the box things like discovery and service to service calls a lot easier than just by using those things. So just wanted to share that here. Let's finish up our last demo and then we can call it good. So we just deployed our, you remember we deployed, hopefully we deployed, published to containers. Okay, so I didn't know I had. So all that talking and there was a message box. So let's try to save time, guys. And now there's an error. So let's see. Did it not take the single switch from single to, so it is single. Oh, that's the API. We want the UI. All right, so let's choose this back to single mode. Switch from multiple to single, confirm. So I have to remember to do this one last. That's weird, I thought. All right, so now deprovisioning. It's kind of funny. Provisioning, deprovisioning. Okay, so let's go back here now. Let's do one more publish, see if we can make this happen. Hopefully it's smart enough to continue right on instead of building it again. Yeah, look at it. I think it was. All right, so here we're now publishing that. Really? UI. Well, how about let's take a look at our prep forecast UI to kind of wrap that up. So in here, we have our one instance or one revision. Under Dapper, we have Dapper disabled. Oh, sorry, we can do the forecast weather front end. Too many examples. All right, so here we do have Dapper enabled. We have the front end. We have it also on the back end. I've already deployed those services. And so when we come here and actually call the API directly, you see, and we call our fetch data, this is actually making a call back to our API. So it wasn't the exact one we created, but this is going to our API and using the Dapper services for that. All right. So that's really what I want to show today. I guess any questions at all?